Hey welders, welcome to a new year. It's 2015 and I hope everything is going well for you so far. We got a long way to go, don't we? Alright, today we are going to be talking about doing some sheet metal welding. If you're a car guy, you know this is something that you're going to deal with on a regular basis. So what I got here are a couple coupons of 60 thousandths sheet, and I'm going to bring that closer so you can have a look, and we'll talk about what we're going to do. Okay, here's our two pieces of 60 thousandths sheet metal. They're about 6 inches long, about 2 inches wide, and they've been cleaned, as you can see. First I hit them with a grinder, then I hit them with a flat disc, and then I wiped them off with some alcohol. Triple clean, because we're going to TIG it, and in TIG likes everything to be very clean. So we've got a pretty decent fit up here. I mean, there's no real gaps there. This is about what you would expect to find when you're working, you know, with shear cut metal. So you can just imagine this as you're working on a quarter panel or a fender or something like that. And what we're going to do is we're going to tack it, probably boom, 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 boom. And then we're going to weld it using this Eastwood TIG 200 AC/DC machine. This is the number 17 torch that comes with the machine. I have on a gas saver gas lens in there with a 3/32 thoriated tungsten, and as you can see I have it sharpened to a point because we're going to be doing moderately low amps. Now for the setup of the machine, this is steel. We're going to be on DC. My control is going to be on the foot pedal. Power is going to be controlled by the foot pedal, so we don't have to worry about that. Also, our AC balance, since we're doing the DC, doesn't matter. I've got 0.4 seconds. I'm going to turn that down to 0.2 seconds on the pre-flow, and I like about 5 seconds on the post-flow. Now, since we're dealing with thin sheet metal and just mild steel, you know, one of the main rules in TIG, well, it's not a rule, but you know, a good practice is 1 amp per thousandth. So we're going to do this butt weld at about 60 amps, but I'm going to tack it at about 110 amps. And what I'm going to do is I'm just going to hit it hard, bang, step on and step off the pedal just like that, and that'll give us what I like to call a flash tack or a fusion tack. You get the idea. So let's get that set up. We'll get this tacked, and then we'll weld it up and talk about. All right, so I've got the pieces laid out here for our tack up. They're butted up against each other pretty tight. The table is clean. It's been also wiped down with alcohol. The pieces are clean. Everything's clean for TIG. Now, when you're working with sheet metal, this thickness or smaller, there's going to be a lot of tendency to work with heat. So you're going to want to get in and get out as quickly as you can. So the flash tacking will help because it will only be a shot here, a shot there, you know, basically like that. And then once we get to the welding at about 60 amps, we're going to want to move. Once the puddle gets going, we're going to move as quickly as we can. We're not going to rush it. But once we establish a rhythm, we're going to keep going. As we get closer, I'm right-handed. So as we get closer to the end, I'm going to roll off the pedal slowly because there's nowhere for the heat to go when you reach the end, and it just kind of builds up and builds up and builds up. So that's what we're going to do. Right now I've got my pedal set for 110 amps max, and that's going to be for the flash tacks. So let's get this thing tacked, and then we'll get started on the weld. Alright, we got it tacked up pretty good there. We're dealing with one solid piece of metal now. Now this time I'm going to turn down the pedal to where we want to be, which is about 60 amps. And we're going to be using 1/16 inch ER70S2 filler metal. So let me get everything set up. And we'll get. Alright, I've got my filler metal, I've got my torch, my power supply set for a maximum of 60 amps. Might take less, could take a little more. If it does, we'll have to readjust. That's the thing about welding, you have to see how the metal is going to react. There's no hard and fast rule. I mean, we can say the rule is 1 amp per 1,000, sure. But depending on the metal, the alloys in it, everything is going to react differently. So you got to see how it's going to react and make changes as you go. That's the mark of a good welder. Am I a good welder? I'm trying to be. All right, let's get on with this and see if we can't not make a mess out of it. Or a big fat magic marker. I want to adjust my angle, have everything just where I like it before I get started, and then we'll go. I'm at about 3/4 pedal here. I'm not moving too fast, not moving too slow. As the puddle moves and swells, I add filler to the leading edge of the puddle. I don't push it in, I don't dip it in, I just touch it, and we let the puddle take what it wants. Now you have to be careful, we're getting towards the end, I'm reducing my amperage a little bit, and you also want to make sure that you keep your angle consistent. A lot of guys tend to let their angle get too wide, their travel angle that is. Coming way off the torch here. Almost at the end. Don't want to blow any holes in it. Alright, we're at the end. I'm adding some extra metal, tapering it out slowly. And after the what you want to call it, flame out, the post flow is done, then you can remove your torch. All right, guys, here's our piece of metal. What I did is I cut out a coupon, like a test piece, like you would use in a school if you were being tested. Now, what you can see here is we've got a good penetration. That is completely down there through the metal, 100%. We've got a nice tight ripple pattern, not much crowning, and you see we got a little, as we're going through there, it gets a little hotter towards the end. In fact, if we take our nice digital calipers here, there we go, and we measure from the center of the weld to the end of the heat affected zone, you can see that that is 1.1 inches. So either we should have went much faster, or the weld should have been much colder. You can see we've got a little bit of deformity from the heat, not too bad, and a nice flat weld on top, so it's not going to take too much hammer work to put that thing in place. Alright guys, that's it for this episode. Thanks to our friends at Eastwood. Check them out for all your welding needs, and I'll see you again.